Number 7 is an addition problem. We did this twice last time. Hope that you remember what we do with this. Whenever you are adding polynomials, you got parentheses around them. Often what you do for a first step is you simply drop the parentheses altogether. So that would be 8x squared plus 2x minus 1 plus 4x squared plus 5. You simply drop the parentheses when you're adding. Once you've dropped the parentheses, then you want to add your like terms. So what is like 8x squared?
4 squared.
That's right. So 8x squared plus a positive 4x squared is?
12x squared.
12x squared. You want to be really careful here. When you're adding like terms, you leave the variable the same and you add the coefficients. And then what is like the positive 2x? Nothing. It's kind of a loner up there. So it just gets dropped down into the answer. Just because there's not something like it doesn't mean that it's not part of the answer. It just means there's something combined with it. It just becomes part of the answer. Lastly, we've got negative 1. What is like negative 1? I think I got that. Positive 5, right? So negative 1 plus a positive 5 ends up being positive 4. I have written my answer there in descending order. There's no requirement at this point unless it says you got to put it in descending order. I'm going to naturally do that because later on that's going to serve us really, really well to do it that way. Let's review really quick. If you were going to name the answer here, what kind of a polynomial is that? Trinomial, right? It's 3 terms. What is the lead coefficient? 12, right? It's the coefficient. If you're in descending order, it's the first coefficient you come to. And what is the degree for this one? 2. Okay, good. You're remembering that really, really well. Okay, so we are going to go backwards a little bit here, and we're going to talk about subtraction, and we'll do a couple of subtractions, and then we'll be done. So if you guys could go back to number 4. How to subtract polynomials. You're going to find that with the exception of one step, this is a lot like adding polynomials. There's going to be a step that you got to show. You just got to show it. So here it is. If you are subtracting polynomials, you can see up here we've got a trinomial minus another trinomial. With addition, we could simply just drop the parentheses and then combine like terms. With subtraction, we can't quite do it like that. It's close. Close to that process. Here's what you actually do. We are going to take this minus sign, the one that's in between, that minus the one that's saying, hey, you're subtracting these polynomials. We are going to take that and we are going to actually distribute that minus sign to the polynomial that's being subtracted. So the way that works is this minus sign gets distributed here, here, and here. And as we distribute that minus sign, we can drop all parentheses. But we have to distribute the minus sign as we drop the parentheses. We can't just like drop them like we did with addition. We've got to distribute the minus sign to that second polynomial. And then once we've done that, we can drop the parentheses. So I'm going to drop these, 3y squared minus 4y minus 6. I'm going to drop the parentheses around those. But as I drop the parentheses around the second polynomial, I've got to distribute. So it's going to look like this. Minus 2y squared plus y, right? And then minus 9. So believe it or not, this is like this distributing of the minus sign, essentially the changing of all the signs in that polynomial. Sometimes can be a struggle. I've seen plenty of times where somebody will do it twice but not the third time, or those forget it altogether. Make sure that you realize you're subtracting, and subtracting is different than addition, so it requires this slightly different strategy. Now once you've done this, it's the same as addition. You're going to hunt down the like terms and try to combine those. So what is like 3y squared? Negative 2y squared. Remember the sign in front of the number, sign in front of the term stays with the term. So when you combine those two, what do you get? Yeah, 1y squared. You could just write y squared if you want. What is like negative 4y? Y. So when you combine negative 4y plus y, what do you get? Negative 3y. Very good. And lastly, you got negative 6 and negative 9. And you try to combine those, you get negative 15. That would be your result. Okay? So I want to give you guys a chance to kind of practice this on your own. So if you would, let's take a look here at, I think it's number 6. No, let's not do 6 yet. Let's do number 8. Jump ahead to number 8. There we go. Give you a chance to do this by yourselves. Work with a partner if you need. Check your answer in a minute. See how this went. First step would look like this. 3y cubed minus 10y. I'm just going to drop the parentheses on the first one. But as I drop the parentheses on the second polynomial, bless you, I need to distribute the minus sign. So distributing the minus sign might look something like this. So it would be minus y to the third plus 9y squared minus y. At that point, I've distributed that minus sign appropriately. I've dropped the parentheses. Now, what I'm ready to do is try to combine my like terms. So what did you guys see as being like the 3y cubed?
The y cubed?
Remember it's the sign in front of the term stays with it, so we'd combine it with negative y cubed. So what is 3y cubed plus negative y cubed? That's right. So we get 2y cubed for the first term. And then we look to that second term. What is like negative 10y? Negative, say again?
Negative y.
Negative y, right there. So those two terms are like. When I combine those by addition, what do I get? All right, so we got negative 11y. And then you can see pretty clearly by all the circles and squares and stuff that there is nothing like the 9y squared. And so maybe we put it right here, plus 9y squared. And we've got our answer. So real quick, if you were going to name that polynomial, what would you call it? Trinomial. What's the degree? 3. You can see that degree right here, degree 3. What is the lead coefficient? 2. Remember, that's the number that's attached to the highest degree term. So it's lead coefficient of 2. All right, so how you guys doing? Okay, so take a look at that next one. Number 9 says try with a partner. There's one more chance to practice subtraction, and then we'll go back to that trapezoid that you saw earlier. Please try number 9. Looks like you guys are kind of wrapping this one up. Let's take a look at your steps. Really, take a hard look, please, at your steps. Make sure that your steps are matching what you're seeing up here. Step number 1 is to drop the first set of parentheses, 3d squared plus 5d minus 9. And then, since we're subtracting, we're going to take this minus sign and distribute it across to all 3 terms in that second polynomial. So it would end up looking like this, minus 12d squared plus 6d minus 11. So take a look at your page. If you've got a step like that, I think we're in good shape. Hopefully we did well after this, but that's a good first step. Do you guys have any questions at all? Want to give you another chance here? Okay. Hey, can you guys? Thanks. Okay. Now it's a question of adding like terms. What is like 3d squared? All right. So when you add those up, Alec, what do you get?
Negative 9d squared.
That's right.
Yep.
Well done. So, Luke, what about the 5d? Is there anything like the 5d?
There's 6d.
6d, when you add those up, what do you get?
11d.
That is also correct. Joel, those last two terms, are they really like terms?
Yes.
Yes, they are. So negative 9, negative 11 add up to be?
Negative 20.
Negative 20. Okay, so check your answer against mine. I think we did a good job. Do you have any questions about any of those 3 terms?
So the coefficient is what goes with the highest degree.
Let's talk about that. Yeah, hey guys, let's do that too. This is a trinomial, right?
Yeah.
What's the degree?
2.
And when we say degree 2, what we're looking at is that 2 right there. It's the highest degreed exponent. And then what's the lead coefficient?
11.
Lead coefficient's not 11. It's easy to think that the lead coefficient is the highest coefficient. It's this. In this case, it's negative 9. And the reason is because that's the coefficient attached to the highest degreed term. If you put it in descending order, it's the term that comes first. That's where you get that lead coefficient. So lead coefficient negative 9, degree is 2 for this one. Okay. Last question for the morning is back a couple. It's that trapezoid. Right here. There we go. So this says, find a polynomial that represents the perimeter keyword. Hey guys, listen up. Let's make sure we're all super duper clear about this. Perimeter. Perimeter means what?
All of that whole outside.
Whole outside. Yeah, whole outside added up. There it is. So guys, I heard somebody say like something about how do you find the perimeter of a trapezoid? The honest truth is, really doesn't matter what the shape is. It doesn't matter if it's a triangle or a trapezoid or a square or rectangle, hexagon, octagon, or some other crazy irregular shape. All you do to find perimeter is you add up all of the sides. That makes sense? So don't think of different formulas for perimeter. Just realize it's always, like Grace said, it's just the sum of the sides. So if you guys would, take a couple minutes, work together, work with a partner, and let's try to figure out what the perimeter of this trapezoid is. Number 6. Walking around, kind of peeking over shoulders. I noticed some of you guys did this in stages. Some of you said, let's add up these two sides and these two sides and combine the result. You can definitely do that. I think I'm just going to write it out in one big statement. I'm going to say that the perimeter of this particular shape is, I'm going to start right here and work my way around. And so it's going to be a squared plus a plus, I guess you could put that in parentheses if you want, plus 2a squared minus 5, and then plus 3a squared. That's just a single term. I guess I won't put that in parentheses. Plus 4a squared minus 2a plus 1. You just write that out in just one long statement. Oh my goodness, I'm kind of off the page there. Let me do a little fixing. Let's just go a squared plus a. How about that? It's still not quite on there. You guys okay with that? Do you know there's an a squared just off the screen? Okay. So when it comes time to add, all we really do is we drop the parentheses. So maybe for a second step you would write a squared plus a plus 2a squared minus 5 plus 3a squared, goodness, plus 4a squared minus 2a plus 1. Okay, so as we go through and we try to add up these like terms, we just want to note what's where. There's an a squared, of course, just peeking off the edge of the page there. Do you guys see how there's another a squared there, there's another a squared there, and there's a fourth one there? There's 4 of them. So as I add those up, I've got 1a squared plus 2a squared plus 3a squared plus 4a squared. Did you guys get 10 a squared?
Yes.
Adding up those 4 terms? Any questions on that particular term? Okay. And then the next one is an a. So I got a positive a. And the only other term that's like that positive a would be the minus 2a. When you add those up, you have a 1a plus a negative 2a. You get negative 1a, or just minus a. And then I've got a negative 5 and a positive 1. Those are also like terms. You add those up, you get minus 4. So check your answer. Did this go okay? I hope it did. Any questions? Hey guys, great question by Cole. I think this applies to everybody. He says, does it matter what order it's in? It really does not matter. You could rearrange this thing as long as you keep the sign in front of the number with the number or with the term. You can do that. So if you wrote negative a plus 10a squared minus 4, that's the exact same polynomial, just reordered. The only scenario where you've got to have the same order is if I were to say, maybe in the direction, say something like, it's got to be in descending order. I think descending order is a place where we want to go to. It's going to serve us really well in the future, but there was no requirement here, so you could have it all mixed up as long as the signs are in the appropriate spots. Anybody else have a question? Yes, ma'am.
Are we still supposed to label it with feet?
You know what? That is a great question. If we're going to do that, it didn't specify, so if this were a quiz or test, I don't think I'd hold you to that. I think I'd only hold you to that if I said include units. But if you did, I'd put this in parentheses and I would say feet. Right there. That's a good question. Last thing, let's do this. Let's do this really quick, just verbally. If you were going to name this polynomial, what would you name it?
Trinomial.
Trinomial. What is the degree? 2. What's the lead coefficient? 10. You okay with that?
Yep.
Okay, fantastic. So we'll leave 5-5 alone for now. If you guys would